For today's discussion, we are going to discuss inverse variation. So what is an inverse variation? An inverse variation occurs whenever a situation produces pairs of numbers whose product is constant. So for two quantities x and y, an increase in x causes a decrease in y or vice versa. So when we say inverse variation, as one value increases, the other one decreases. So we have here the phrase y varies inversely as x. So always remember the term inversely. So we write the equation as y varies inversely as x. So we have the constant of variation k. So remember when when we say y varies inversely as x, we define the inverse of variation wherein it produces pairs of numbers whose product is constant. So meaning to say, to solve for the value of k, we simply multiply the two quantities y times x. So always remember that in inverse variation, to solve for the constant of variation, you multiply the two quantities. So let us express each of the following statement as a mathematical equation. Number one, the number of pizza slices P varies inversely as the number of persons N sharing a whole pizza. So P varies inversely. So for number one, that would be P varies inversely as the number of persons. So we have the constant of variation K inversely to N. So number 1 is equal to P is equal to K over N. How about number 2? The number of petchay plants N in a row varies inversely as the space S between them. So we write the equation as N. So that varies inversely. So do not forget to write your K to the space S. So that is number 2. How about number 3? So it is important that we know how to write the equation. The number of persons N needed to do a job varies inversely as the number of days D to finish the job. So meaning to say the number of persons N varies inversely. So you have your constant of variation. Inversely, it varies inversely to the number of days. So we have your equation now. So let us take some examples. The rate R at which a person types a certain manuscript varies inversely as the time T spent. So you have the rate R. So for number 4, so R varies inversely as the time T. So K over T. Now if you are asked to solve for K, again, what I said, we multiply the quantity. So here, if you are going to solve for K, K is simply multiplying the two quantities R and T. So the same goes with all the equations for inverse variation. So for example, number 5, the cost C per person of renting a private resort varies inversely as the number N of persons sharing the rent. So meaning to say, C would varies inversely to the number of N. So the constant of variation is K over N. So if you're going to solve for K now, K is equal to multiplying the two quantities Cn. Then last, the length L of a rectangular field varies inversely as its width W. So L varies inversely. So you have your K, that is constant, over W. Now, to solve for K, to solve now for K, we multiply the two quantities. So that would become your K is equal to LW. So inverse of variation is something like if you are going to pay for something and the more the person that will pay that amount will be lesser the share. So as the one value increases, the other one will decrease. So let us have another example here. So I have your table. We use table of values. We find the constant of variation. Remember that the constant of variation is equal to the product of two quantities. So in this case, that would be k is equal to xy. So let us choose a pair. For instance, this one. 1 times 2 is 2. 2 times 1 is 2. So 3 times 2 thirds, if you let me show you the solution, times 2 thirds. So this will be 3 divided by 3 is 1. 1 times 2 is 2. How about 4 times 1 half? So 4, when you multiply it to 1 half, will become, so when we divide this, 4 divided by 2 is 2. 2 times 1 is 2. So the constant of variation is the same. So you have 2. How about this one? You have 2 multiplied to 36. What is 2 times 36? So the constant of variation for all this quantity should be the same. So 2 times 36, that is equal to 72. How about 4 times 18? Will it be 72? Yes, that is also 72. So the same. How about 6 times 12? That is also 72. So, and 8 times 9 is also 72. So, meaning to say your k here is equal to 72. Now, let me just show you the graph of a inverse variation. So, this is the graph of an inverse variation. Take note, if your L is 6, so let me have your L is 6, and your width is 2. Okay, what would be the next pair? You have 4 for length and 3 for the width. If you have, okay, let's get this one. This is exact. You have 2 and you have 6. I want you to notice that when the value of L decreases, the value of W increases. So that is an example of inverse variation. And when we multiply, we get the value of k. 6 times 2 is 12. 4 times 3 is also 12. 2 times 6 is also 12. Okay. Another example. So find the equation and solve for k. Y varies inversely as x, and y is equal to 6 when x is equal to 18. We simply write the equation. So y varies inversely as x. So y varies inversely as x. Now we are asked to solve for the equation. So we first solve for k. Again, I told you that to solve for k, we simply multiply the two quantities. So this is all only possible for the inverse of variation. So your k now is equal to, what is your y? 6, and your x is 18. So times 18. So what would be now the product of 6 and 18? That is 6 times 18 is 108. So our k now is 108. So the first question is we find the equation and solve for x. So now this is our original equation. We simply substitute k. So your equation for this one is y. Substituting now the value of k, which is 108, divided by the value of x. Okay. Let us have another. Y varies inversely as x, and y is 10 when x is 2. So this is the first part of the equation. Then we find y when x is 10. The first step is always write your equation. Y varies inversely as x. So that is y varies inversely as x. So you might ask me, why are we going to multiply the two quantities? Take a look at the solution. The denominator of y is 1. By cross multiplication, k times 1 is k, and y times x is yx or xy. Now, let us solve for k. The value is 10. So k now is equal to 10 for the value of y, and x is equal to 2. 10 times 2 is 20. Now, after solving for the value of k, we substitute this to the original equation, to this one. So y now is equal to, k will be replaced by 20 over x. So this will be now the equation that we are going to use to answer the next statement. Find y when x is 10. So y is equal to 20 over x. So by substitution now, given is 10, your y now is equal to 20 divided by 10. And 20 divided by 10 is 2. So meaning to say, the value of y is equal to 2 when x is 10. Okay, let me rewrite 2. So that is 2. Oops. So we have 2. Okay. So your y now is equal to 2. Another, p varies inversely as the square of q. So let us write the equation. P varies inversely, so you have your constant of variation k, to the square of q. So q is raised to 2 to the square of q. Now p is 3 when q is 4. So again, our case, the product of the two quantities, so that would be p times q squared. By substitution, p is 3, so that will be equal to 3 times q is 4. Do not forget that it is raised to 2. So we first raise this to 2. So 3 times 4 squared is 16. So what is 3 times 16? 3 times 16 is, okay, correct, 48. So our k now is equal to 48. So the value of k is equal to 48. After getting the value of k, we substitute that to the equation. So this will become p is equal to, your k is 48, so we substitute that by 48 and over q squared. So the question now is we find p when q is 16. So p is equal to 48 divided by, your q is 16, so 16 raised to 2. Okay. So we first simplify this one. 16 squared is, so we rewrite 48. What is 16 raised to 2? That is 256. Now, we are going to rewrite this into its simplest form. So, what is the number divisible to both 48 and 256? So, let us try 16. 48 divided by 16 is equal to 3. And 256 when divided to 16 is, okay, correct, that is also 16. So, meaning the answer now is 3 over 16. So this is your final answer.